we have started with double and compound angles. We went through all the different types of identities. We're now starting with the next concept in double and compound angles, which is called trig substitution. Now, grade 12s, if you have seen, I know the minute I put it up here on the board, you've already seen this before. Okay, you've seen if sine 21 is equal to A, they can change this angle, make it any angle. Sine 36 is equal to P. Sine 28 is equal to Q. It doesn't make a difference. The minute you see a problem looking like that, it falls under the topic of trig substitution. Now, we need to do this without the use of a calculator, guys, because we need to give our answer. The question says in terms of A. So you cannot use a calculator. Your answer will be in terms of A. You'll have an A in your answer. Now, how do we do it? Here, method or the strategy of attack. Okay? Let's get started here. Whenever we see this, I'm going to give you an acronym. Like I gave you guys an acronym for solving identities. I told you Ali. Who does identities? Ali does identities. What does Ali stand for? AL, step number 1, algebra. Step number 2, identity. So do your algebra, look for your identity, the problem will work itself out. The method or strategy of attack for this one is called scrap. S-C-R-A-P. Now you might be asking, you have absolutely no idea what it means. Now the word scrap represents the steps involved in sorting a problem out like that. So the first S stands for standard form. The C from scrap, draw your Cartesian plane. The R stands for look at your restriction. Are any restrictions given in this problem? No. A and P Pythagoras. Always get your problem in standard form. Draw your Cartesian plane. Look at your restriction. Complete it using Pythagoras. So the method of attack to solve these types of problems without the use of a calculator, whenever it says without the use of a calculator by using a diagram, you use this method called scrap. What does scrap stand for? Standard form, Cartesian plane, restriction, and Pythagoras. Let's apply. So, before we even start answering the questions, but you need to draw the diagram, guys. You get marks for the diagram. You get marks. So now, put your diagram down here. Put your diagram down there. Let's see, is this in standard form? Yes, it is. Sine 21 equals A over 1. Okay, so it is in standard form. I'm just moving this up here. Let's put it here. We say sine 21 is equal to A. We know A is A over 1. Now, using SOHCAHTOA, we know that is opposite over hypotenuse. You guys all know SOHCAHTOA. For 90 degree triangles, sine opposite over hypotenuse. Cos adjacent over hypotenuse, tan opposite over adjacent. So, standard form, S, there's your standard form. Cartesian plane, there's your Cartesian plane. Restriction, any restrictions given? No. And Pythagoras. So if no restriction is given, we draw our triangle in the first quadrant. Our reference angle here being 21 degrees. Now we know it's sine. Sine opposite over hypotenuse. So opposite, that's your opposite. That's your hypotenuse. That's your adjacent. The side opposite your reference angle is your opposite. We know that the side opposite our 90 degrees, that's our hypotenuse. And the remaining side being our adjacent side. So now, opposite over hypotenuse. Opposite over hypotenuse, A over 1, that must be A, that must be 1. We're short of our adjacent side. Now don't get confused. The A from the question and the A from adjacent is not the same A. They represent, it's the same alphabet representing two absolutely different sides. So this is actually our X value. So we want to find out what is our X. Now we use Pythagoras. And what does the theorem of Pythagoras state? The square on the hypotenuse is equal to the sum of the other two squares on the other two sides. We need X. We need that value there. So now we've got 1. 1 squared is 1. Minus A squared is equal to X squared. So X is equal to plus or minus the square root of 1 minus a squared. Now, we know it's to the right, so this must be the square root, positive, the square root of 1 minus a squared. If this was on the opposite side, it would have been negative the square root of 1 minus a squared. But it's on the positive side of 0. Any number to the right is positive. Okay? Please, another mistake that many of you make. You say that the square root of 1 minus a squared is 1 minus a. In which world? In which world is the square root of 1 minus a squared equal to 1 minus a? Never in your life. So it's one of the biggest mistakes. You leave it as the square root of 1 minus a squared.